Hey, what is going on everyone? I'm Wicked, welcome back to my Dart from Novice to Expert complete course. In this tutorial, we're going to start a long tour of Dart language with all of its quirks and features. We'll begin by having a quick recap of everything we learned so far, then we'll move over to checking out everything about Dart variables and the difference between Var, Dynamic, Final, and Const keywords. So without further ado, let's get right into it. Beforehand though, I want to send a token of appreciation to everyone supporting me as official YouTube members, especially to Diana and Michael aka Aza on Discord. If you want to become a member, all you have to do is to click the join button right next to my channel and pick your desired membership. Having that said, let's continue with our tutorial. As I said, before diving into the tour of Dart language, we must do a quick recap of everything we learned so far, in order to refresh our mind for the huge chapter that's going to come up next. One thing to be noted is that this language tour will have its base on a null safety Dart environment. Everything you're about to hear and see is based upon that. So, over the last 9 tutorials, we learned that Dart is an object-oriented programming language, meaning that mostly everything in Dart is a class, and objects are instances of these classes. Numbers, functions, and even null are objects. As an example, take a look and observe that each of these types are actually classes behind the scenes. No matter what it is, integer, string, list, object, null, everything has its origins and implementations in a class. As any other programming language, Dart comes with variables, and everything you can place inside a variable is an object, which is actually an instance of a class. As an example, if we take a look at this line of code, you must know that 5 is actually an object instantiated from the integer class. It's pretty much like writing int a equals int with a value of 5. Dart is a strongly typed language, meaning that everything has a type. However, explicitly annotating it is optional because Dart can infer the type by using the var keyword at compile time and by using the dynamic keyword at runtime. As an example, if we write in var a equals 5, then variable a is going to be of type integer, and we know that immediately after the assignment. However, if we type in dynamic b equals 5, then variable b is going to be of type dynamic, and only at runtime the type of b will be set to integer. As a result of this, dynamic can be used to postpone type checking until runtime. Therefore, it is really helpful to use it when you want to explicitly say that any type is allowed for a variable. We'll talk about the differences between dynamic and var later on this tutorial. Dart is a sound type system, meaning that it can never evaluate into an unknown state. Under the hood, everything is clearly defined before the execution process. And since we're in a null safety environment, variables can't contain null unless you specifically say they can. A variable can be nullable by placing a question mark symbol at the end of its type, just like this. If you strongly believe that an expression will never evaluate to null, but the Dart analyzer does not agree with you, you can add the exclamation mark symbol to tell him that it won't be null, and throw an exception if it is. As an example, a variable of type string question mark might be a string, or it might be null. However, if you want to assign it to a non-nullable string, you must postpend it with the exclamation mark just like this. Dart is an ecosystem based on packages. Every Dart project is actually a package nevertheless. Every package can depend on any other packages, and you can decide whether other packages can depend on yours or not. Packages use libraries in order to share their code one with another. The code outside the lib folder of a package is not accessible to anyone. And this is pretty much what you should remember that is necessary to know before diving ourselves into the complete tour of Dart language. Either way, you can go and rewatch specific tutorials if you forgot something about the things I covered inside of them. Now, think of the road ahead as being a long train journey. We're in the Flutterly train, and the first stop we're going to take on this tour of Dart language is at the keyword station. Now, I'm not going to spend a lot of time talking about all these keywords. you'll even get to know some of them in great detail during this tutorial, and the rest of them during the next tutorials. However, at the same time, you need to know some minor but really important key facts about them. Ideally, on a daily basis, you should avoid using these words as identifiers. Yet, you can notice that some of these keywords are marked with a superscript. If really necessary, you can use those as identifiers. A variable identifier is actually the name you give to that variable. Words with the superscript 1 are called contextual keywords, meaning that they have meaning only in specific places from inside the code. Take the on keyword for example. It is normally used inside a throw-catch statement, specifying on which type of exception you should do something in response to. However, the on keyword can be used as an identifier to a variable signaling that a car is perhaps turned on. Words with a superscript 2 are valid identifiers in most places, but they can't be used as a class, type names, or import prefixes. For your quick knowledge, import prefixes can be seen in this example. We can import something and annotate it into a small prefix, so that we can later access it by using that specific prefix. Words with the superscript 3 are really limited, reserved words, mostly related to the asynchronous huge advanced topic. We'll cover that up later on this course. The thing is that you can't use await or yield as an identifier in any function body marked with async, async star, or sync star, since they have a ton of meaning in this case. All other words in this list are reserved words, meaning they can't be used as identifiers under any circumstances. Having this said, it's finally time to talk about Dart variables. In Dart, you can mainly find 4 types of variables: top level, static, instance, and local variables. And they're all split apart like this depending on where you declare them in your program. So, first and foremost, in Dart, you can declare a variable that is not linked to any class or object and that can be accessed from anywhere else in your program. This is called a top-level variable. You might also know it from other programming languages as being a global variable. On the other hand, since everything in Dart is mainly an object, you'll find yourself most of the time working with variables that are tied to objects and classes. These are static and instance variables, and you'll often find instance variables being referred to as fields or properties of a class. You'll also find local variables, which are variables that have a local scope, meaning that they can only live and be accessed perhaps in a local context of a method or function. Having all of this in mind, in Dart, a standard variable declaration looks like this: string car equals BMW. However, it can easily become as complicated as static, late, final, integer equals check temperature. But we'll get to that later on, so let's talk about the components of the standard one first. Car is the variable name that is also known as the identifier. BMW is known as being the value of the variable, and at the same time it must be an object instance of the same type as the variable's type. In our case, BMW is a string object instance that was assigned to the car variable of type string. The equal sign is an operator denoting the assignment process. String is also called the type of the variable, and it can be non-nullable just as it is right now, or nullable if we postfix it with a question mark. What you need to know is that variables in Dart store references to an object. Therefore, the above car variable is just a reference to a string object with a value of BMW that is located on Dart's internal memory. The assignment operation of a variable to an object, denoted by the equal operator, is optional. However, Dart does not allow a variable to hold absolutely no value. If no assignment operation was done, then Dart will assign a default value to that variable. The default value Dart will assign a variable to is null. This will work fine with a nullable variable since it can be assigned to null by default. However, you know that a non-nullable variable cannot hold null. Therefore, a really important rule you need to keep in mind is that non-nullable variables must be initialized before you access or use them. Notice that I said before you access them and not exactly right at declaration. In order to study this subtle difference more in depth, let's take a look at the rules on how you should declare a variable, whether it's a top-level, static, instance, or a local one. Top-level nullable variables can be left unassigned at declaration and will be assigned a value of null if so. Or you can assign them at declaration with a value of the right base type or with a value of null. You can even assign them later on, and it doesn't matter if you do it before or after using the variable. However, take in mind this can result in null exception errors. Non-nullable variables, on the other hand, must be declared at declaration with a value of the same type, as they cannot hold a default null value. If you won't assign it at declaration, Dart will show an error preventing you to compile the program. However, another approach here is that you can assign a value to the variable later on, only if you're 100% sure it is going to be assigned before it will be accessed. You can do that by using the late modifier. What this modifier essentially does is permit the variable to hold no value until it gets initialized. If you fail to initialize a late variable and you try to use it, then a runtime error will occur. If you don't know what a static variable is, it is a variable that can be accessed without having to instantiate an object from the class it was placed into. So you can simply call them like this. As a consequence, you can't initialize a static variable in a constructor of a class. So the question remains whether you need to assign it at declaration or perhaps later on by using late. Nullable static variables can be left unassigned at declaration and will be assigned a value of null if so. Or you can assign them at declaration with a value of the right base type or with a value of null. You can even assign them later on, and it doesn't matter if you do it before or after using the variable. However, take in mind this can result in null exception errors. Non-nullable static variables, on the other hand, must be assigned at declaration with a value of the same type, as they cannot hold a default null value. If you won't assign it at declaration, Dart will show you an error preventing you to compile the program. You can initialize the static variable later on, but necessarily before it is used by using, as before, the late modifier. Instance variables, compared to static variables, exist only within an instance of a class. So we must also take into consideration the constructor of the class in our initialization workflow. Nullable instance variables can be left unassigned at declaration and they will be assigned a value of null, or you can assign them at declaration with a value of the right base type or with a value of null. Or you can assign them in the constructor, whether it's formally as an argument to the constructor, into the initialization list, or even right inside the constructor body. You can even assign them after the constructor, and it doesn't matter if you do it before or after using the variable. However, take in mind this can result, as before, in null exception errors. Non-nullable instance variables can be assigned at declaration with a value of the same time, as they cannot hold a default null value. However, it is not required to assign them here. You can assign them to the constructor, whether it's formally as an argument to the constructor or into the initialization list. However, you can't initialize it into the constructor body, so you need to make sure you initialize it before it reaches the constructor body. On the other hand, you can also initialize the instance variable later on, even inside the constructor body, but necessarily before it is used, by using, as always, the late modifier. Local variables are variables having a local scope. You can, for example, declare a local variable into a function and it will only be available inside the scope of that function. This makes it much more easier for the Dart analyzer to scan if it will be assigned before use. Nullable local variables can be left unassigned at declaration and will be assigned a value of null, or you can assign them at declaration with a value of the right base type or with a value of null. You can even assign them later on, and it doesn't matter if you do it before or after using the variable. However, take in mind this can, as before, result in null exception errors. Non-nullable local variables can be assigned at declaration with a value of the same type, as they cannot hold a default null value. However, it is not obligatory to assign them here. If you won't assign them at declaration, it is required to assign them before you use them inside the scope they were declared in. Not doing so will result in an error and Dart won't let you even compile the program. As you can see, in this scenario, since Dart can 100% take care of the state of the local variable, you don't really need the late modifier for the expected behavior. In order to visualize all of these scenarios even better, I have created a table on how to correctly declare your variables. You can pause the video and see if it makes sense for you. For example, you can see that nullable fields are optional all the way because they can contain the default null value issued by Dart. However, null can cause null exceptions, therefore it's like playing with fire with them. In the case of non-nullable fields, let's take the top level ones as an example. At declaration, if you don't plan on using the late modifier, it's required to initialize it with a correct value. If you won't, Dart will show you an error. If you'll use the late modifier, then it's optional to initialize it where it was declared. But as you can see, it's required to initialize it before using it. For instance fields, however, if you don't plan on using the late modifier, it's optional to initialize them at declaration, but it is required to do so before the constructor body, and not doing so will result in an error. If you use the late modifier, then you can initialize it whenever you want, but it is obligatory to do it before you'll access or use that variable. Hope it makes a little bit of sense. It is not required to learn all of these. The Dart analyzer will help you and tell what's wrong if you're trying to break any of these rules. But it's better to have a general idea on how you can declare a variable in different scenarios. We currently saw the late modifier in action when we wanted to assign the value of a variable later on, after the declaration. However, you can also use the late modifier onto a variable and assign it a value right where you declare it. In this case, the late modifier serves another purpose of lazily initializing a variable. For example, when you mark a variable as late but also initialize it at its declaration, then the initializer runs right after the first time the variable is accessed and used, and not when it's been declared. This lazy initialization can be handy when the variable might not be needed, and initializing it takes a lot of time and performance. For example, let's say we have a class with a static integer variable retrieving a time-consuming calculation of the temperature from a weather sensor. We're using this class, instantiating it with other fields, but we don't actually want to create this variable every time since it's not performance efficient. We can fix this by marking it late. Moving on, as I said before, in Dart, type annotations are optional because types can be inferred at compile time by using the var keyword or at runtime by using the dynamic keyword. So let's see the difference between them more in depth. It's time for a showcase between var and dynamic. Therefore, first and foremost, let's create 3 var fields and assign them to an integer, a string, and a list of integers. As you can see, if we hover over the variables, we already have the compile time types right after we typed in the declaration. Let's go ahead and print the runtime type of each variable to double check that they won't change at runtime. If we run this file now, you will see that the runtime type is the same as the compile time type. So what we can observe from this is that var vi equals 5 is absolutely equal to writing integer vi equals 5. So are the other ones. In comparison with var, dynamic is more like a standalone type telling the Dart analyzer that the actual type will be set at runtime and not before compile time as we're used to with var. Creating and declaring the same 3 fields, this time marking them as dynamic, we can see that if we hover them, their actual type is dynamic. It's more like saying these variables can be of any type right now. However, the actual real type will be assigned to them at runtime. So let's go ahead and print their runtime type. If we run the program again, you can notice that the runtime type is the same as with var. And a quick note on dynamic is that even though this dynamic field is a list of integers, if we try and access an instance method from inside the list class, let's say the add method, the Dart static analyzer won't give you an autocomplete option for it, since as far as he's concerned, he doesn't know yet the type of the variable. It will only be found at runtime. So why would we want to use dynamic instead of var? Well, let's see what happens when we try to set the var vi variable to a double value. As you can see, Dart will pop up an error telling us that we can't assign a variable of type int to a double value. Therefore, what we can deduce from this is that if we set a var variable to a value, then the type of that variable can't be modified anymore after it has been set. On the other hand, if you try the same scenario with dynamic type, you can notice that it actually works, and at runtime, the first type is of type integer, then after it got assigned to a double value, the type got changed right away to double. And this is thanks to the runtime being able to switch types in real time. But now you might wonder what is going to happen if we declare a var x variable and we won't assign it to anything. What will be the type of x? As you can see, the compile type of the variable is actually set to dynamic by default in this case. So this line is actually similar to saying dynamic x. Therefore, an unassigned var variable has the same benefits of being a dynamic variable. As a result, since it's basically a dynamic variable, we can set it to multiple types of values that's going to denote its type at runtime. The real question now is what happens if we just leave the var x unassigned and run the program just as it is. We know that an unassigned var x is the same as writing an unassigned dynamic x variable. So at runtime, if there's been nothing assigned to it, what's the type of variable x? Well, the type will be of the default type, and that type in Dart is, as expected, the null type. But wait, that means dynamic type is actually nullable, right? And yeah, that's completely true. Even though it doesn't have a question mark appended at the end, dynamic type is a nullable type, so it's valid to be of type null. So, dynamic is really useful when, for example, you have a list of different kinds of values, like integers, strings, and doubles. All you have to do is to set it as being a list of dynamic type, so that for each of the values, the type is set accordingly. That was the showdown between dynamic and var. But let's extend this battle by adding another two competitors, which are Final and Const. The battle now resumes between dynamic versus var versus final versus const. What I can tell you at first is that the order in which I told you these keywords is actually the order from the least restrictive to the most restrictive kind of variables you can declare in Dart. Dynamic being the least restrictive and const being the most restrictive. So we currently know that dynamic can change the type of the variable, and the variable can be reassigned later on inside the code with any other value, whether it's of the same type or not. Var can't change the type of the variable unless it's not assigned to anything when declared, which actually makes it dynamic. But the variable can be reassigned later on inside the code with a value compatible with its declared type. Well, a final variable, similarly to var, can't change the type of the variable. However, the variable can't be reassigned to another value later on. A const variable can't change the type of the variable, and the variable can't be reassigned to another value either. So then what's the difference between final and const, you might ask? This is a really important question, so please pay a little bit more attention to it. First of all, let me get one thing straight. Const can not only be used for variables, but also for values, as well as constructors that will create a constant value or object. And speaking about constant values, you've been using them without knowing all of this tutorial. what do you think happens when you type in integer a equals 5? Well, variable a isn't a constant variable, but it is assigned to a constant integer value. It's like writing integer a equals const integer with a value of 5. You notice that even though 5 is a constant value, variable a is not, so I can reassign it to another integer later on. Currently, variable a is neither final or const, even though it's been assigned to a constant value. However, constant variables are a little bit different. What I can do is I can make the variable a constant, so that not only the value will be constant, but the entire line of code will practically become a constant. I can now no longer modify the value of a, since the entire variable is literally glued to its constant value. A rule to be taken in mind is that denoting a variable to be constant makes the value of it to be constant too. However, the other way around is not true. Assigning a constant value to a variable doesn't make the variable become constant. On the other hand, compared to const values, there is no such thing as final values. Final variables, similarly to constant variables, can't be reassigned. They only get assigned once. However, the slight difference is that final variables don't make the value they're assigned to as being constant by default, just like a constant variable will do. For example, if you have a final list containing 1, 2, 3, you can actually modify that list by adding, removing other elements from it later on in the code, and that's because it's not constant by default. However, since it's still a final variable, you can't assign the list to another list, for example. The thing is that you can actually make the list value as being constant just by adding the const keyword as we previously saw. This way, the final list equals constant 1, 2, 3 is actually equally the same as writing const list equals 1, 2, 3 if you think a little bit. Dart even warns us that we should use const instead of final for this. If we compare the hash codes of these two lists, we can actually see they are the same since they point to the same compile time constant lists. So, from this we can conclude that final was created to mark variables non-reassignable while still being able to hold non-constant values and modify their content later on. Whereas constant variables must be assigned to constant values, which are absolutely immutable by default, and if they won't, they'll automatically convert them to constant. This also applies to an object. If it is declared final, as long as its fields are not final or const themselves, they can be reassigned. However, let's see another important fact. Concentrate on this final list variable here. Note that if we try to add a value to the list variable, the static analyzer doesn't say anything, even though we can clearly see it is assigned to a const value. Is it possible to mutate a const value? No, it isn't, but the thing is that Dart only knows that the final list variable has been assigned to a constant value only at runtime. So only if we run the program we'll see that it ends up throwing a runtime error. So here's another important difference between final and const variables, and that is that final variables will have a value known at runtime, whereas constant variables must have a value known at compile time. You can't assign a constant variable to a function calculating a sum of two numbers, since the result of that function will only be retrieved at runtime. Instead, you should use a final variable to store that. Another thing to be noted is that if you want to have a const instance variable inside a class, you have to declare it as static const rather than just const, so that it can be accessed at compile time without having to instantiate the class at runtime. Therefore, const can be used only for top-level, static, or local variables. Instance variables are not supported. A huge advantage of using both final and const for classes is coming in terms of performance. Let's say we have this class A containing a list of integer values field which is going to be instantiated into the constructor of the class. If we create two classes with the exact same list and print their hash codes, we'll notice that even though it seems like they both reference the same object from memory, that's not true, and two different objects are created and referenced. However, we previously said that the const keyword can be used as a constructor to generate const values. In our case, a const object, right? So what happens if we tell Dart to create two constant instances of the A class? Well, it obviously won't let us before the constructor of the A class is not marked const. And if we make that const, you'll see another error pops out, and that is related to our list field not being final. So why does our list need to be final? Well, previously we learned that every const variable will make its value constant, right? Well, think that the constant variable is actually our class right now. Right, we're actually trying to implement a constant constructor for our class variable, right? Then that means all of its fields also need to be somehow constant. And since class fields cannot be constant unless marked static, the only choice we have left is to mark them final and let them hold constant values. If we check the hash code of our variables now, you'll see they match, both referencing the same constant object in memory, which obviously can bring huge performance increases in the long run. I hope you really understood the difference between var, dynamic, final, and const. So, if we go back into the keywords table, we can mark the ones we discussed today. And surprisingly, we can notice we actually covered some important ground right from the start. It is finally time to end this long tutorial on Dart variables. I hope you really understood them in depth. In the next tutorial, we'll move over to the next station on this Dart language tour, and that is the Dart built-in types station. As always, if you like this tutorial, don't forget to smash that like button, subscribe to my channel, and share the video with all of your friends and colleagues in pursuit of top-tier development. Until next time, as always, take care, Wicked is out, bye bye.